In this video we're going to finish off the special cases. So if we head back into the special cases section, we're going to cover this area here. It's called the multiplex. Now in the top level here you'll see that we have an answer after the rounding, so this in effect would be the final answer. But what we're going to do is we're going to split it. So normally this point here would just run straight to here and this would be the output, but we split it at this point and this value here heads up into the special cases, and then there's an output from the special cases here which finally feeds to this final output. So we've split this here because we want to introduce the possibility of there being another route to the output, that is via the special cases. So if we head up into special cases here and we head into the multiplex. Now this circuit is very similar to the one we've done with the multiplier, so if you've covered that then a lot of this will be a bit of revision. So if we're using the adder and subtractor as normal, then we would have the output would come from here and it would feed straight through and to the output here. But if we're changing the output to include special cases, then these special cases here, plus infinity, minus infinity, plus 0, minus 0, nan, x and y, can pass through to the output instead of this. So in effect this cuts off the adder and subtractor and then just puts in these values instead. So the path is changed directly through here as opposed to through the adder and subtractor. Now what we're going to do is do the test here. So the test is going to occur down here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 9 special cases. Now those go through a NOR gate. So if all of those are low, that is we've got no special cases, then it means that this side here is going to be high. If this side is high, then this line here is high. That means we're going to choose value 0 here for the multiplexer. So value 0 for the multiplexer is just the normal route through the adder and subtractor. So there hasn't been any special cases and we just use the adder and subtractor as normal. Now if any one of these go high, which you can see at the moment, we're going to have plus 0 is high at the moment. You'll notice that the other side here is low. So if the other side is low, it means that we don't choose this value here, value 0, and the choice is made down here for one of these, 1, 2, 3, 4, 5, 6, 7. So one of these 7 values is chosen instead. So these 7 values are going to give the values up here, which are the plus infinity, minus infinity, plus 0, minus 0, nan, x and y. And those are chosen here from our inputs, which we have here. So for example, if we're going to have a plus infinity output, we would have that if this plus infinity tunnel had gone high. So if the input's telling us here that it's a plus infinity for the final value for the output, then we're going to have to pass that plus infinity to the output. Now there's another option as well, because we can pass the plus infinity not just from here, but also if there's an overflow. So there could be an overflow to plus infinity, so that would also trigger this one. And the same here for minus infinity and an overflow to minus infinity, and you get the same for the underflows for plus and minus and not a number. And we've also got the values for plus and minus x and plus minus y. So these give us the other output options. Now you'll note here as well, we've got this extra section here. Now this is placed in so that we can provide some output flags at the top level. So we're going to have a flag here for underflow to plus 0, minus 0, overflow to plus infinity, minus infinity, and a not exact. And we're also going to have the option here for putting out the final type of addition subtraction. That is, if we have n, it means we've got a normal number coming in, another normal number coming in, and the output is going to be a normal number. And if you look at the last one here, we would have a subnormal coming in, a second number would be a subnormal, and the answer would be subnormal. So in the addition and subtraction, we're going to have 1, 2, 3, 4, 5, 6 possible cases that we have to take care of. And you can see here that if all of these values here are low, then we're going to have a high output here. So that means at this point here is going to go high. And we're going to have the possibility of having a +0, that is an underflow to +0. And we could also have it via the underflow here. So if this here goes high and this is high, then again we can have an underflow to +0. So those are two different routes for getting the underflow to +0. And we've also got the underflow to minus, and we've got the overflows, and we've also got the not exact value coming out here. So that's another route for these outputs. And finally, we've got the values here which come in for the normal, 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 and normal, normal, subnormal, and so on and so forth, and those pass out through these outputs here. So if you're unsure of any of the circuitry, you can always go in and put a few numbers in and then just check the ones and zeros and check and see what particular point goes live and is high and what particular point is low, and you can chase the ones and zeros throughout. Now that covers most of everything we need to know about the special cases, but there's one other section here, and you can see here it's got the output type. So this is where I worked out whether the outputs are going to be normal, 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 subnormal, and so on and so forth. So if you head in here, well, you can see that I've generated a normal value and a subnormal value within this unit. So I've just regenerated it here, and you can see that we've got the input here, and it tells us whether the input is a normal or a subnormal for both the x and the y. And it also tells us whether the output here is a normal or a subnormal. Now we only really need one of these because the output is either a normal or a subnormal, so we can just do this one test here. And finally, we get the final outputs here just by negating the relevant inputs. So for example, this one here, normal, normal, subnormal, if the xn and yn here are values of 1, then we know that we've got a normal input, so we just place these in here to the AND gate, and if we get a subnormal output whenever the normal has been inverted, and this is the inversion here. So we could in fact replace this norm here with the sub if we'd wanted to, but it doesn't matter, we'll keep it just simple and we'll keep all of them as normal inputs. So that gives us all of the values that we require at the output. Now if we head back up here, you'll see that we've got the outputs here. Now these outputs are going to be fed directly to the output at the top level. And this is output at the top level, so they all come out here and they get into the various flags. So we've got our flags here for our special values on the right, and we've got our flags here for the addition and subtraction types, okay, on the left. Now only one other little thing to mention is in the sticky bit here we've got our not exact. So our not exact here is going to come out whenever we get any one of these bits and the output goes high. That is, we're going to have at least one bit shifted out of the addition or subtraction. If we've got one bit shifted out, in effect it means it's lost, and we're going to have a not exact answer, even with after our rounding has occurred. So that is really everything that we need to know about the special cases here. And that is us covered everything that we need to cover within our adder and subtractor. So in the next video we'll go ahead and we'll put in some test scripts and we'll see the adder and subtractor working. So thank you for listening. I'll get you on the next video. Goodbye.